Hello, in this video I'll demonstrate how to use Worklight native iOS API in a Swift application. So I'll create a simple application that will invoke adapter and display feeds. So for that, first of all, we'll need an adapter. It's gonna be HTTP adapter. Let's call it my adapter and deploy it. So this adapter, it's a default HTTP adapter. It has getStoreAsFiltered function, and I'll use getStoreAsFiltered, and as interest I'll say technology. That's the feeds we'll want to display. So if I run it, let's see. Okay, so that's the invocation result. I can see the result, the filtered feeds for technology taken from Engadget, if I'm not mistaken. See, no, that's CNN RSS. Okay, so we have our adapter working. So now let's create native API. New Worklight native API. Let's name it RSS feed reader application environment iOS finish. Okay, so it contains several folders. The folder for Worklight API, that's basically the Worklight code itself, and the plist file that basically contains the settings for my server, and that's my local IP and all the application properties. So once again, run as deploy native API. I'm deploying it, and just to see that everything is intact on Worklight server, I'm opening Worklight console. And yes, I can see that I have my RSS feed reader application, and I have my adapter. So those are the server-side artifacts I'm going to use. Good. Now let's go for the native application. So I'm going to open the new Xcode 6 beta. Going to create a new application. Right. So it's gonna be a simple single view application. I'm going to call it, let's say, RSS reader application, and it's gonna be Swift, universal, core data, next. So create it. So give me a second to resize the Xcode. Good. So this is going to be one very simple application. Okay. Let's wait for it to start. Okay. So if I go to the storyboard, I want to create use a table view. Okay, so the application will display a table view, and this table view will contain the feeds I've retrieved from my Worklight adapter. So I'm going to define data source to my view controller, because that's the view controller that's going to provide me with data, and I also want to create outlet that will allow me to refresh table view once feeds are retrieved. So table view connect. Okay, so I'm good to start. So let's go to the view controller. So my view controller will implement UI table view data source, and this protocol basically means that I need to implement two mandatory methods: number of rows in section and self for row at index path. So let's do it here. Table view number of rows in section, and table view self for row at index path. Okay, so let's see. I'm going to use an array to store my feeds, right? So it's gonna be feeds array. I'll initialize it as empty array, right? And number of rows in session, I will return feeds array count. So initially it will be 0, so no rows will be displayed, and after that, for now, let's say it will return nil. And once I've retrieved my feeds, I will add some code to actually add some elements. So as you can see, I can see my empty table, no feeds yet because I haven't really retrieved them yet. So this is the basic thing. So let's see. Okay, so let's feed item. So for example, it will be the item from my feeds array. So once I've retrieved it, I will actually get it, right? So here I'm interested at object and index path, not item, right? So this is the way I retrieve it from my feeds array, right? And since it's going to be an array of dictionaries, I will say as dictionary, right? So my cell will be UA equals UA table view cell, and the autocomplete helps me here. The style, let's use the default style, and reuse identifier, my reuse identifier. Okay, so and cell.text. Well, eventually I will use feed item title, right, as string, and return cell. So that's going to be my code. So but before I actually start using that, I need to retrieve my feeds, right? So and that's where the Worklight code comes in. So for now, if I start my application, I will still see the empty array because I don't have any feeds retrieved yet. Okay, so let's start adding Worklight framework into my Swift application. So first step to do is take the Worklight API folder and put it here. Right, I will copy items if needed, create groups, finish. So now I have my Worklight API inside of my project. Second thing is to take the Worklight plist file. That's the one that contains all the Worklight server settings. I'm going to put it, let's say, to supporting files. Okay, copy, finish. Okay, so now my application contains both Worklight plist, that's the file that contains the server settings of my application, and the Worklight API, that's the folder that contains all the Worklight stuff. Okay, so now we need to add frameworks, the framework that Worklight application depends on. You can really see the list of frameworks in Getting Started module or Worklight Info Center, right? I'll just add them here one by one. So the first one is CF network. Then we also have system configuration framework. System config, we have mobile core services, core data, security. As you can see, iOS 8 already has all of those frameworks. SQL Cipher will already have it inside. And the last one is core location framework. Okay, now I have all the required libs and frameworks added, right? So what left to do is go to the project build settings, find headers, right? That's search headers which I want my builder to use, and I will add here new entry for src root / worklight API / include, right? Well, sometimes it doesn't work. Okay, so basically that's the reference to this folder. Okay, so this means that during the build, it will go to the include folder and look for all of those headers. Okay, so if I build my application now, see, it will succeed. So linker flags, the last thing to do is go to the linker flags, wait, and add minus Objective-C. Okay, so now I'm all set to go to use Worklight APIs. But however, the problem is if I want to use Worklight APIs in my Swift application, right? So for example, on view.did-load, I want to load my feeds. It doesn't really know about the existence of Worklight. So since Worklight is implemented in Objective-C, I need to add a bridging header that will actually make sure that the Objective-C headers are bridged into my Swift part of the application. So I'm adding new file. I'm adding a header file. I will call it RSS reader. That's the name of my application. Waging header. Okay, so I will copy it because I will need it in a moment. I'm adding it to the target RSS reader. Create. Okay, so that's the header that basically will contain all the headers that I want my Swift code to know about. So just you know, a very simple. I want to import wl.h. Okay, so I build my application. I can see that it's working. I can import my WL client. I can see that it's working. And what's left to do in build settings? Okay, so I need to define the name of my bridging header. Okay, so now when I build my application, build is succeeded, right? But when I go to my view controller and start to use WL client, I got my autocomplete. So WL client dot shared instance dot pretty much anything I need. Okay, so once again, the steps for adding WL client is first you add, steps for adding Worklight API, first you drag and drop the components from Eclipse to your Xcode Swift project, then you add your frameworks as defined in the documentation, right? And the new thing that you need to do in order to be able to use Objective-C API in your Swift application is create bridging header and add it to your build settings. Okay, Objective-C bridging header, here you define your bridging header. So pretty much every header you import here will be available to your Swift code. Xcode takes care of that automatically. So let's see, what do we do now? So since I already have my WL client, I need to invoke adapter procedure. So let's do that on view.did-load. So let invocation data be WL procedure invocation result. I still don't have my procedure invocation data here auto-completed because it's a different header and I need to add it. So I'm going to bridging header and I'm saying import WL procedure invocation data.h. Right, saved. Going here, WL procedure, and now I have autocomplete for procedure invocation data, which is exactly what I need. So adapter name would be my adapter. Give me a second. My adapter, yes, that's the adapter name I've defined in Eclipse. So procedure name would be get stories filtered. Okay, and one more thing I need to add here, invocation data. Parameters is I need to add the filter I want to use, because this procedure implementation, the get stories filter procedure requires interest, so I can use world, Africa, sport, technology, or any other that CNN RSS feed actually supports. So I'll use technology, right? Let's copy paste technology and we can use this very convenient syntax. Okay, so next thing to do is WL client dot shared instance dot invoke procedure, and invocation data, well, that's invocation data, and delegate, that's self. Okay, so I'm going to fix this in a moment, but here, as you can see, I have autocomplete for WL client shared instance invoke procedure. So I can see this autocomplete since I've imported to my bridging header all the headers that are required for this API. So this is basically WL client, right? And also WL procedure invocation data. So if I'm not importing a header for any of the parameters of that API, I will not see it either. Okay, so if you can see the WL client but you cannot see the invoke procedure, this means you've only imported WL client header but you forgot about W procedure invocation data header. Okay, so but still we can see there's some problem here, and the problem is could not find an overload for invoke procedure that accept the supplied arguments, which is correct because currently self this class doesn't really implement WL delegate, the protocol you need to receive data, to actually receive responses callbacks from invocation. So I'm going to add it here with WL delegate, and WL delegate basically means two functions, on success and on failure. As you can see, I'm getting autocomplete automatically. Right, I don't have to do anything else. That's because my WL delegate is already imported. It's part of the WL client and WL procedure invocation data, so I don't need to look for it. It will be auto-completed automatically. So here I want to print line that will say on success, just to see that it works. As you can see, I'm still used to semicolon, and here I want to print line on failure. Right, so well, let's try running it. Application successful, bit success. Okay, so and we have an exception. Let's see what this exception means. Assertion failure, terminated app due on code exception, could not add keychain item. Okay, so the problem is here is in order to access keychain, you need your application to have entitlements, and I haven't defined any of those yet for my application. So the basic way to solve this type of exception is to mark your application target, go to capabilities, and here I want to add keychain sharing. So I'm clicking OK, I'm enabling it. It will ask for your development profile, so don't mind the error right now. As long as it's enabled, it should be functional. So let's try running my application again. Okay, so let's see. Oh, that's the line I wanted to see, on success. So this basically means that the procedure invocation was successful, and now I just need to manipulate the data to actually see my result. Okay, let's see, on success, what do we do next? So first of all, I want to say that feeds array is response, get response JSON, and it contains items, right, as NS array. So let's make it a little bit more interesting here. Print line response text. So just to show what exactly is returning from the server. Okay, so as you can see here, what's returned from the server is a JSON object, right? So currently you can see it as text. And this JSON object actually starts with a property called items. And items is an array that contains all the items. So if I'm going to return get response JSON, right? So if I'm going to print response JSON, you will see it in a much more structured way. Okay, let's see what it starts. Items is an array with multiple dictionaries. Each dictionary has keys like description, link, pub date, title, UID, etc. Right? So I'm interested just in a title for the sake of simplicity in this demonstration. So I'm not going to print it anymore. I'm going to get the response JSON, then I'm going to get the property called items, that's the one, and I'm saying as array, that's basically casting it to an array. So once I've done that, basically I want my table view to reload data, right? Reload data will cause table view to refresh, and this time the feeds array count is more than 0 because it's not an empty array anymore, right? And all of the cells will be actually rebuilt with the title in mind using this property. Okay, so let's see if it works. Running the application, and as you can see, all the feeds were retrieved, and now we can see the titles in the list, right? So if, for example, I change technology to, I don't know, sports, and run my application, okay, I can see the error, probably because there is no sport available in CNN. Let's try sport. They should be functional. Yes, they have sport. So now it's all about sport. So basically, that's the very easy and convenient way to use Worklight native API in your Swift application.